So over the summer, I bought this Capehart N2 console amplifier. The seller had no idea what it was. I think it was listed as tube amp big transformers 1950s or something like that. Um, yeah, not very descriptive, but I had been browsing tube amplifiers on eBay all summer, and so I kind of was able to recognize it when I saw it that it was a Brooks Capehart amplifier. Anyways, it was from the late 1940s actually, like a post-war amplifier. It came in. It's an N2. It's the official like Capehart name for it is an N2 amplifier. You can see that on the schematics in the service manual. But most people who are selling these don't really know what they are, or they don't include the N2 name. They sell it as like Capehart 6L6 amplifier or something like that. But yeah, of course, the amplifier was never sold as like a standalone thing. It only came in the consoles. I think any Capehart console with an N2 suffix, so like a 114 N2, and I think there was a 112 N2 as well, has this amplifier inside of it. But yeah, anyways, I thought it would be kind of a fun project. It's a really, really simple circuit if you look at the schematic, at least the amplifier part is. And then it's got a bunch of like extraneous wiring for powering the tuner and some other parts. But of course, we're only going to be restoring the amplifier here. I don't have anything else. I don't have the tuner or anything like that. But yep, just wanted to restore the amplifier for use just to, general music listening. And I only have one of them, and it is a mono amplifier, of course. So I'm not really sure what I'm going to do. I'm trying to find a second one, but so far haven't found any singles, and the pairs that are on eBay are really overpriced. So I guess I'll just have to wait for something to come along. So before we flip it over, I might just talk real quick about what we've got on the top and kind of the basic layout of the amp. So the big transformer right here is the power transformer, which has both the B plus and the filament taps on one transformer. And it's very large. I'm not exactly sure why. I think that this chassis ran the power supply for some of the other components in the console, such as, the tuner and whatnot. So that might have been part of it. And this big connector right here, I don't know how easily you can see that, but it's got a bunch of female connectors right there. That ran an umbilical that connects to some of the tuner and the other stuff. So I think that's part of the reason this power transformer is so overbuilt. I also wonder if it might have been designed to run on 25 hertz mains, which obviously requires much thicker core. But anyways, so that's the power transformer right here. This is the output transformer. And then you've got the 6L6s in these two sockets and the dual 5U4s on these sockets. And again, the dual 5U4s are pretty unnecessary for like a 20 watt push-pull 6L6 amp. I think it was due to running the other parts of the console, and also just wanting to have a really long-lasting power supply. And then over here you have the four 6J5 tube sockets. The 6J5 configuration, one 6J5 is a preamplifier tube, and then you've got a phase inverter, and then the driver tubes for each 6L6. So that's that. And then these are both power supply chokes. I don't know if I mentioned that yet, but yeah, dual power supply chokes, really beefy chokes, and then dual power supply caps, 20 microfarad times 4. Multi-segment can caps. And then over here are the connectors. This one is the auxiliary connector, which is the one we're going to use to feed the RCA, the signal, unbalanced line signal in to this connector via a custom cord that plugs into this, and the other end is terminated in an RCA. And then this is a microphone input that's hooked up to a pot, which we're not really going to touch this at all. We might actually disconnect that jack completely just to prevent it from picking up noise and whatnot. And then yeah, there's not much else on this amp. The chassis is a really thick steel. A lot of the weight of the amp is the chassis and the power transformer. Yeah, very, very, very thick chassis. not really exactly sure why they decided to use such a thick gauge of steel, but you know, makes for a very durable amp. There aren't like any dings on this chassis or anything because it is so thick. And then there are two fuse holders. One of them is out of the shot back here, and then another fuse holder over here. Yeah, and I think both those fuses are good. I tested them. One is for the mains and one's for the B plus, if I remember correctly. Yeah, so there's not really much else to this amp. Just a simple chassis, tube sockets, you know, the iron, and then these, which we are going to remove and replace with you know, modern connectors. So a modern line cord input, and then, you know, speaker jacks and an on-off switch. All right, so here is the underside of the N2. As you can see, a bunch of stuff is mounted on turret boards. So there's a turret board over here with the coupling caps for the 6J5s. 6J5 sockets are up in this corner here. And then we have rectifiers, outputs, this big main turret board up here, which you can't see that well. Maybe I'll try to tilt the whole thing backwards a bit. And it's not much better. Anyways, there's a big turret board up here. We're gonna get all these turret boards dismounted. They are held on by just little nuts, like you can see right here. So we're going to get all the turret boards dismounted so that I can access all the resistors on there, and also sort through some of the wiring and make sure everything is according to the schematic. And I'm also going to redo some of the wiring, like some stuff doesn't make sense. Like, look at the length of this lead that connects one of the coupling caps to the socket. Like, this lead is like ridiculously long. I have no idea why. I presume that wasn't factory original wiring. That would be pretty sad if it was. But anyways, yeah, there's some questionable wiring, and there's also the heater wiring, which was redone, which I need to go back and restore to the original wiring. Yeah, so first order of business is going to be removing all these turret boards so that I can sort that stuff out. So originally I was going to start with replacing a bunch of the components like I just said, but as it turns out, the wires in this thing are really disgusting, to be honest. They had some like mildew or something on them. They smell really musty and overall just kind of unpleasant. So I've actually decided to start with replacing all the wires, which is something I pondered earlier and I had decided not to do because it's a lot of work, but upon looking at it again, I really do think that it needs to be done. And this thing will look much nicer. As you can see, so all this is the original wiring. I actually went ahead and replaced one wire already beforehand, which is this one right here. You can see it's different, it's thicker, the insulation's thicker. And it's just a new cloth wire, so I went out and got 4 colors of brand new cloth wire. There's 2 of them. I've got the other 2 off camera. And so I'm going to be replacing the existing wire with this new wire. And yeah, so I'm just going to go through the whole entire amplifier and take out all the wire except for the leads that are attached to the chokes and transformers, because those would be a real pain to redo for obvious reasons. I mean, the wires go into the inside of the transformer, so I'd have to either like make a connection on each one and then plug the new wire in, or open up the transformer and do something. I mean, it would just be a pain. So in the end, I'm just going to redo all the wires that aren't leads of a transformer or a choke. And I'm going to do that before I get into replacing the components. But for right now, I'm just attaching the new wires physically, but I'm not soldering them in yet because I figure I'm also going to replace all these resistors, and I might as well do the soldering only once rather than doing it once for the wires and then another time for the resistors when I go back. So anyways, yep, that's going to take quite a while. I'll probably just show a bit of a time lapse of that right now. All right, so at this point, it's time to deal with this can cap right here. A bunch of stuff is attached to it, and I want to get it wired up, the new one wired in correctly before I kind of forget what's going on here. So, so let's just first take a quick look at how this is configured. So, so these two legs right here, it's a 4 times 20 microfarad can cap. These two legs right here of the can cap are tied together, creating one 40 microfarad segment. So that connects, the 40 connects to this, which goes off to the tube, the output tubes, and then also connects to this blue lead right here. So these two connect to the 40, and then there's a 1K resistor which connects the 40 and one of the 20s right here, and this 20, you can see the resistor, this little resistor, and then one of the 20s goes up to here. So we've got the new lead wired in right here. And then the last 20 segment is a standalone, and it connects to this yellow lead right here. So the first thing I'm going to do is get the old one out, and then we are going to install the new one, and the new one is a 40 times 20 times 20, so there's no need to tie those two leads together. Just use the 40 as one, and I've already got the 1K resistor right here, kind of tied in. So it's a 3 watt 1K. So we will just tie the blue and the one of the brown leads into here, the other brown lead into here, and then the yellow lead into here. All right, so the tabs on the can of the capacitor are soldered to this metal kind of mounting bracket ring thing right there. And I briefly tried to desolder them using my normal TS 100 soldering iron, but it wasn't going to work. That thing doesn't have enough power. So we're going to give it a shot with the big 80 watt Weller with the huge chisel tip, and hopefully that'll do it. All right, so after a lot of effort, this thing is finally free from the metal tab that was holding it in. The 80 watt soldering iron was enough. It takes forever, like almost a minute to heat up from being cold, but it was enough to get these tabs desoldered. And so yeah, we got this off. Luckily, the other one is insulated from the chassis and doesn't have the case soldered to one of these metal brackets. So we won't need to do that for the other one. But you can see this one is quite gross. Glad to get it out of there. And I doubt it's good. Actually, we could test it on the ESR meter and see what it reads. I doubt it's good. And even if it was, I would want to replace it just for peace of mind. But anyways, so that's finally off there, and we can get the new one mounted. So this rightmost lug right here is the 40 microfarad section, and then these two are the 20s. And as you can see, like on the old cap, we have a 1K resistor between the 40 and one of the 20s. So yep, just gonna put this in. I'm actually going to mount it with the bracket on the outside. So yep, just gonna be mounted, it's out of focus like that. So I'm gonna use the old screws. Actually, we're not going to use the old screws because they don't really fit. They could screw in potentially. They're almost big enough. All right, I'm going to not completely redo the wiring to that cap right now, because a lot of the wiring that needs to be done is on the other side of the amp, over here on the little power supply board, and I don't want to flip it around, so I'm just going to go back to working on the 6J5s over here and cleaning up all this stuff, and I'm going to remove these 3 coupling caps so I can have better access over here to kind of just get rid of the rest of this messy wiring over here. So you can tell these caps definitely need to be replaced because you can actually see on this one on the board right here, see that black residue right there? That looks like where the wax coating sealant on this cap, or one of them, I don't know if it was this one in particular, actually melted onto the board underneath the turret board. So yeah, I'm pretty sure those would be bad and definitely need to be replaced. They've seen some heat. They all look kind of melted and messed up, all the wax caps on this thing. So yep, going to replace those in a bit, but right now I'm going to focus on the wiring. All right, so you can see here that I finished up the wiring on the 6J5 sockets around here. In addition to redoing all the wiring to the sockets, I also replaced the coupling caps. I forgot to turn on the camera when I did that. But anyways, these are the 3 coupling caps for the 6J5s, and they've all been replaced as well. So the next things to do are, first of all, remove the input connector, which we'll do right now, and then replace that. And then afterwards, we need to replace the heater wiring. So like I mentioned before, the schematic for this amplifier includes an elevated DC heater, 30 volts DC elevated above ground, drawing power from the B+. But for some reason, this amplifier, as it was built, doesn't seem to have ever incorporated the elevated heater. I'm not sure if this was an early version and the elevated heater was added later, and then the schematic I have is maybe for a later version, or the opposite, if the elevated heater was in the earlier version and then removed for cost reasons or something like that. But anyways, this one does not have the elevated heater, so I'm going to need to, I'm actually decided that I'm just going to add in the elevated heater like it is on the schematic. So that's going to require adding 2 resistors for the voltage divider that draws the DC from the B plus supply. So I think I'm going to do that addition over by the output tube sockets, and then just run the heater wiring over to here. And I think before doing the heater wiring, I'm also going to solder all of these connections on the sockets, because I think that it's going to be hard to get an iron in to solder those once the heater wiring is in as well, because it's going to get really cluttered around these sockets. So yep, that's the plan, starting with the removal of this little guy over here and replacing it with the new one that we bought. All right, so now for redoing the elevated heater circuitry. As I said earlier, the heater is normally elevated on DC. So basically there is a voltage divider between the B plus and the heater coil, and the so one of the resistors for that voltage divider is this 220K. This 220K resistor connects the B plus to the heater, and then a 22K connects the heater to the chassis. So you basically get a voltage divider with a 220 between the B plus and the heater, and then a 22K, which gives you about 1/10 of the voltage that you started with. So that should give us, since the B plus supply on this amp is about 360 volts DC, the elevated heater supply should bring the heater voltage up to about 36 volts DC, and then of course you have the 6.3 volts AC superimposed onto that. But yeah, so the way we're going to do that, the simplest way I can think of to, just get this implemented, is to just run the 220K resistor between the B plus pin on the output tubes, and then run that down to the heater pin right here, and then run the heater pin to the chassis with a 22K resistor. So unfortunately the heater pin has way too much solder on it, and there's nowhere to stick this in. So we're just going to desolder this heater pin right here, and then once that's desoldered, we'll connect this up into there, and then we'll connect the 22K to here, and then we'll begin rewiring the rest of the heater wiring, because I removed it given that it was previously set up for a ground return kind of scheme. So it needs to be completely redone, and this will be the first step. Alright, so I'm stopping with the heater wiring for now, because if I go any further, the wiring on these sockets over here is going to make it difficult to solder the pins. So I'm going to just take a break on that for now and finish the heater wiring once I've already soldered all the other connections on those pins for these 6J5 sockets. Instead, I'm going to move on to working on the power supply. So a lot of the wiring in the power supply over here is kind of extraneous wiring that has to do with the connections to the other parts of the console, such as the tuner. So a lot of this needs to be removed, and basically the excess wiring has to be gotten rid of. These sockets are going to be taken out, and of course all the other wiring in the power supply cleaned up as well, and this relay also needs to come out, because I'm still not exactly sure what it was for, but whatever it is definitely not necessary now. It's not a delay on the B+. It's on the primary side of the transformer, so it doesn't have anything to do with the B+. So anyways, yeah, that can safely be removed. And yep, so let's get to that. All right, so now you can see on this capacitor, the one we replaced, we've got the wiring nicely fixed up. Yep, everything looks good there, and we've got one of these resistors that goes across. I might add a bleeder resistor across some of these, but I don't know, I'll decide on that later. But now we're going to get rid of the other cap, this one right here. This one has all of the multiple segments you can see joined into just one big 80 microfarad cap. So yeah, this lead, this black lead right here comes out of one of the chokes. And then this, the other positive lead that connects right here goes over to the dropping resistor, and then the negative lead right here, it does not actually contact the chassis. It's not on ground, but it actually connects to some resistors on the terminal board over here. So anyways, the first step is going to be just removing this cap using, using the flathead screwdriver and the vice grip to just kind of get rid of this. And then we'll insert the new one and wire it up. So now that the cap is gone, I'm going to put the new one in there, but I'm just going to take this opportunity to clean this area up a little bit. As you can see, it's gotten like the black heat scorch marks from this big power resistor, which probably gets up to like 100 degrees while this thing operates, and you can see it's produced some kind of burnt substance on here. So I'm just gonna clean this up a little bit while we have everything out, while we got the cap out. Just kind of, probably should have done this before putting these wires in, but I can move them out of the way. All right, that looks pretty good. Now we need to add in the new cap, of course. So this one, on the original schematic, it's floated, it's got something here. It's floated off the negative side of this cap is floated above ground by, I think it's about 16 ohms. Two 33 ohm resistors in parallel. I'm not sure exactly why the negative is floated off the ground by a bit, but I don't want to mess with anything, so I'm just going to leave it like that. That's why we were using an insulating bracket, like a phenolic insulating bracket for this one instead of the metal bracket on the other one. Yeah, so anyways, that means this one doesn't fit as well, so I have to really twist the tabs on there in order for this to be attached to the bracket. Yeah, so just gonna do that with the... All right, I think that's pretty good. This seems to be on there well enough. No one's gonna be like pulling this thing off. So that should be perfectly fine. So yep, just going to mount that real quick on there. Oh, the other thing actually before we mount that we probably want to do is, so like I said earlier, on the old cap, you can see all of the tabs are joined together to just create one big 80 microfarad cap. We're going to do the same thing here, obviously, and it's probably easiest to do that while it's out and not in there. So yeah, it's not long enough. I'm just going to take some little bits of wire and join all three of the segments together. All right, so we've got the connections between the tabs made here with some wire. So time to just mount this up. Again, I'm just using the screws that it came with. I'm not bothering to buy new ones. Actually, it looks like these screws might actually need to be screwed in. All right, now we can wire this cap as well. And the first thing we need to do is to wire the choke lead back to the positive. All right, now it's time to replace these two wires. This one which goes to the positive of the cap, and then connects right here to this turret that goes also to the big power resistor, and then this other one which goes up to some resistors up here. Yep. So I'm gonna get these gross wires out of here. All right, so on this tag board, there are 3 more wires that need to be redone. There's this one right here, which goes from the fuse holder, and the other side of the fuse holder goes into one of the chokes. This goes to, I think, the one of the pins on the on a rectifier, and if I touch it over here, yeah. So that goes to that pin right there, and then which makes sense. And then this goes to one of the pins on the output transformer, I think, or one of the windings. Yeah, right there. Over there, you can't see that, but. And then this wire right here goes to one of the windings on the power transformer. Yeah. So anyways, those 3 need to be redone, and we'll do that right now. I also need to desolder here so that I can get the hole opened up again, because right now the hole is closed on this pin, or this tab on the fuse holder. So I'll have to do some quick soldering to get that desoldered. We'll run that wire first over to here, and then the wire from here over off to there, and then this one, I have to figure out, we'll do that one in a second too. Yeah. All right, so I just took care of the last 2 wires coming from this turret board over here. This one which goes to the center tap of the power transformer, and this one which is the B plus for the output transformer. And I also wired these connections to the rectifier sockets together. So the last thing to do is to tackle this area, which I discussed before, is the umbilicals for the other parts of the tuner, and we need to determine which wires are the mains power, the line voltage input here, and then also I'm going to disconnect these 2 caps because I don't have the proper Y2 safety caps for the line filtering there, so we're just going to remove both of those for now and not replace them. But anyways, before I can get at any of this and kind of trace everything out, the first step is going to be to remove this relay, which we're not using. So, and it's kind of obstructing the stuff. I can't really see the stuff that's underneath because a bunch of the transformer leads come from right under here. So anyways, first thing to do is to remove this guy. All right, so the relay is off, and I just want to really quickly show what this relay does. It's pretty weird. Of course, it's not a speaker protection relay because tube amps don't generate DC on the speaker output, so there's nothing to protect against. And that's what you'd normally see relays for typically in an amplifier is some sort of speaker protection circuitry. And you know, time delay, like they delay the speakers until enough time has passed, which also avoids the startup transient noise, etc. But anyways, that's not what this is. Tube amps don't have that. What this is instead is actually a weird means of controlling the power to the power transformer. So what I have here is these leads on my multimeter set in continuity mode wired across the input, just the line power input. And you can see there's no continuity, which is weird because this amplifier does not have a power switch. So normally you'd expect there to be continuity between the, you know, both sides of the transformer primary winding, because transformer primaries and all windings on a transformer are just pieces of wire, and they look to DC voltage, they look like they're shorted. So this is strange that there's no continuity. And in fact, this relay is the reason there's no continuity, and you'll see that. So this is of course in the de-energized state because the whole amplifier is de-energized. But when I push this down to simulate what the coil being energized would do, you can see that, put the light back on. You can see that now we have continuity for our power input. So now the power transformer would actually be receiving power. So this is pretty strange. I don't fully understand why, but when you look at the schematic, you can see that I assume that this coil just takes 120. And what you can see is that continuity across this coil would probably be created in another part of the console. So the umbilicals actually send the connections to this go into the umbilical. So when you plug in the other parts of the console, I'm presuming something would create continuity across this, which would then, maybe it allows other parts to warm up first before you give power to the whole amplifier or something, or it ensures that parts of the console are plugged in and have continuity across them before giving power to this. I don't really understand what it's for, but anyways, yeah. So without the umbilicals plugged in, with this wiring, this will never turn on, even if you put a plug into the power socket, that'll never turn on. All right, so after looking at it for a few seconds, it's pretty obvious what the two primary leads of this transformer are. One of them, of course, is connected to our relay. You can see because it goes right down into the transformer. And the other one comes up and connects to our line filtering capacitors right here. So that's this one, and if I put up the beeper, you'll be able to see that this is clearly, these are the primary leads. So right, we got that. And then, yep. So anyways, so I can just go right ahead and, I can go right ahead. You know, I don't know if I want to cut it off. Yeah, I probably do, because we're not going to be using this, at least not for the moment. That goes down into, yeah, over there. Well, in any case, we can definitely cut this one off and say that these two leads are our primaries for the power transformer that we need to wire up once we get into the next video. Definitely not this one. This one's almost over. But we'll be wiring up the connectors using these holes, and of course our power switch. We'll switch the connection here. So anyways, we'll deal with that later, but yeah, so this relay now can just be completely removed because there's nothing more to learn about this. None of the rest of this wiring. These two things are the only things we're interested in. Everything else here is completely extraneous. So I'm just going to start cutting everything off, and yep. So there goes the relay, and you can get a better look at it. Looks pretty much the same on both sides. Pretty interesting. You've got like this insulated kind of paper stuff here, and on the other side. And yep. Oh, it's got, looks kind of Western Electric-y. I don't know if it is. It's got a serial number 90215. Kind of want to put 120 volts on this and see if it activates the coil, but then again, I don't want to like light it on fire. Anyways, that'll go off to the side for now. So at this point, it's basically safe to just go ahead and cut everything off here, and just try to get this cleaned up. So that's everything here. Should be, yeah, we got one more. I suspect that possibly without being connected to anything else, our voltages on the B plus are going to be way too high. So that's probably something we're going to need to deal with down the road. I mean, of course, I'll power it up on a variac, so we'll see if the B plus is hitting the correct voltage at like 100, volts on the line, then we're gonna, then we'll know the nature of our problem. I mean, this thing's probably intended to run on like 110, 115 anyways, so I'll probably need to run it on a bucking transformer, regardless of the issue with the lack of load from the other tubes on the other tubes connected to the B plus that you'd have in the tuner, but that might just compound it, so our bucking transformer might need to bring down the voltage like 20 volts instead of 10 or something like that. Yeah, I don't know. Anyways, you can kind of see what these might be at this point. Let's actually cut all this stuff off because it's the most disgusting wiring in the whole amplifier. And move this over a little bit. Is these guys right here. They're the reason I decided to rewire in the first place. Ugh, gross. All right, we got it. The big prize right here. This mass of shitty wires. So, all right, now the rest of these are actually, the rest of these wires right here are actually connected to the transformer. Of course, we don't need them, but I'm gonna have to figure out what to do with them. I'm gonna cut them nicely for now. Oops. Oh, that's a thick one. Yep. And get this guy right here. Like that. All right. These leads aren't particularly nice. Now we can go about removing the rest of these connectors right here, and then I think that'll be it for this video, because there really isn't much else to do before going on to putting in the new connectors and doing all the soldering and replacing all the resistors, which is the last thing we need to do here. Alright, so that's going to be the end of this video. We made a lot of progress, and obviously the video is going to be pretty long at this point since the wiring took so long. So I think the rest of it's just going to be covered in the next video. So yeah, I'm just going to give a quick recap of what was accomplished. Of course, all the rewiring of everything around here and also the power supply stuff. The new heater wiring has been added in, at least to the output tubes and this one socket. And we've got the voltage divider added in as well, and then and of course the wiring over here was sorted out, all the extraneous stuff removed, and then the new filter caps and the input jack over here. Yeah, so what's still left to do? Still need to solder the tabs on all the tube sockets. Still need to replace all these bad resistors and the caps that weren't done last time. And still need to add the power switch, the binding post for the speakers, and the new power receptacle in here as well. Yeah, so that's going to be all for the next video. And once that's all done, and to solder up and finish the cord, the new cord that's going to be used to use this jack with a normal RCA connector. But yeah, so in the next video, all that's going to be done, and then if everything looks good, I'm going to put it on the variac, bring it up to voltage, and see if everything looks good. If there's no excessive current draw, then we will run some test tones through it, sine waves, square waves, see what it looks like, and then if all looks good, play some music through it. So yeah, that'll all be for the next video. Yeah, I hope you enjoyed this one. And also you might notice that this camera looks a little different than, the quality looks a little better than the previous clips. That is because I've actually purchased a new camera that I'm using to film this outro that will be used in the next video. Well, it's a new phone rather, because I use my phone as a camera, and I can now shoot 4K 60 FPS. I mean 30 FPS rather. So yeah, so the next videos will be in true 4K. And yeah, it should be nice. So I'm looking forward to that. It'll probably be a while, but I hope you enjoyed, and thanks.